I don't know about you, but I just love the algebraic method. That graphical method, oh man, it's just it's a great way to confirm that you did the right thing. But man, to me, algebra is just a lot easier. Look at this mess. Ah, man, another one. But now it's a non-primary. It's one of those secondary trigonometric values. Oh man. Okay, so what? Do the same thing as before. Put an a in here, and you're going to find that this is a squared minus 3a minus 28. Well, that's simple. You can do that one, I hope, in your head. So this is going to be a here and an a here, and you know that this is a minus 7 and a plus 4. This is all going to equal to 0. So you're going to, again, find the zeros. How absolutely incredible, joyous, and triumphant. Okay, so write this out. A minus 7 equals to 0. A plus 4 equals to 0. Now, put the a back in. Remember, this was cosecant. Cosecant of x minus 7 equals to 0. This will be cosecant of x plus 4 equals to 0, and solve. All right, this is then cosecant x equaling to 7, and this is cosecant x equaling to minus 4. Beautiful. Okay, so we're good. Everything's fine, right? Yeah, but the only problem is this is cosecant. Okay, what was cosecant? Remember, cosecant is the same as 1 over the sine. So why don't we take each one of these now and make them 1 over sine, and let's figure out what we got. Okay, so if this is now sine 1 over sine x, we flip this guy. So guess what? We just have to flip this guy. 1 over 7. Oh, that's easy. How about with this guy? Same nonsense. This guy now is going to be sine x. Flip it. Minus 1 over 4. Oh, how beautiful. Okay, don't forget to still stick to your guns here. And remember, add sugar to coffee, right? Okay, so where is your sign positive? Sign is positive here and here. Okay, so you got a value out this way, and you got a value out this way. Now, find the absolute value of this, which is pretty easy. That's 1/7. Realize that we have to be in degrees here. Okay, so let's find this theta reference right now. Bringing up my calculator, I realize that it's in radian mode. Ah, boy, that means I got to change it again. Oh, I wish we could make up our mind, hey? All right, so mode, bum, ba, bum, 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 degrees, enter, second quit. Perfect, we're ready to go. Now, so what value do I need? Oh, I need the inverse sine, both sides of, guess what? 1/7. Okay, perfect, I can do that. Here we go. Inverse sine, second sine of 1/7. Okay, punch it. What do I get? Oh, look at that. I got 8.2 degrees. 8.2 degrees because it is in degrees, right? So it's 8.2 degrees. No problem. I can figure this out. I can do it. Here we go. Back to here. I'm at 8.2 degrees. So my reference angle, 8.2, my reference angle here, 8.2 degrees. So what's my answer? My answer is 8.2 degrees, which is this guy, of course. Now, how do I find this answer? Remember, it's from 180. So 180 minus 8.2. Now, if you want to do that on a calculator, do it on a calculator. I don't care. Go 180 minus this guy, 8.21, which gives you an answer of 171.78, nearest degree, 172 degrees. So this works out to be 172 degrees. How nice. There's that answer. There's that answer. Perfect, right? Right. Now, let's go over and solve this guy. Same nonsense. Where is sine negative? Sine is negative. Add sugar to coffee. It's negative here and negative here. Let's find out what those reference angles are. Remember, to find out the reference angle, then, we make that an absolute value. Okay? So we got to find sine x of a quarter, inverse sine, both sides, right? Inverse sine, that cancels out, giving you x equals to the inverse sine of a quarter. So, okay, inverse sine of a quarter, second sine of 1 divided by 4, there's our quarter. Answer is 14.47 degrees. 14 degrees is close enough. So we're looking at 14 degrees here for our theta reference, 14 degrees here. Meaning, what is this actual angle? It's 180 plus the 14 degrees, which works out to be 194 degrees. And this one would be 360 degrees minus the 14 degrees, which works out to be 346 degrees. Okay? Right? Makes sense? Makes sense. Okay. But what's the one thing we didn't do? Do you see it? But you don't. I bet you don't see it yet. Do you see it now? Yeah. The restriction on this problem is between 0 and 180. So guess what? You don't need this answer. You don't need this answer. The only two answers you need are this one at 8.2 degrees and this one at 172 degrees. So you're probably saying to yourself, well, then why did he even do these? Why did you do these? Because guess what? It's going to ask you for the general solution. And you have to remember that if you think about these, being that they're signs, remember, there's no number up front here. So every one of these has got a period of, guess what? Yeah, 2 pi or 360 degrees. So to state the general solution, you have to state 4 general solutions. The first one is this guy. So you go 8.2 degrees plus n. I'll use n this time. I like using k, but the book likes using n, so I don't care. N times 360 degrees. That's the first one. This one's going to be 172 degrees plus n times 360 degrees. So multiples of 360 degrees. Then you got to do this one out here. 194 plus n times 360 degrees. And then 346. Let's make this degrees. There it is. 346 degrees plus n times 360 degrees. Oh my gotcha. Yeah, it's crazy, isn't it? Now, the big thing that you have to remember to put in there is n is an element of the integers, which tells you that you can go forward or backwards. That's how you solve this question.